Hi everyone, welcome to my YouTube channel. Today we are going to study the new concept called numerical solution of ordinary differential equation. Theoretically, we have n number of methods to solve normal differential equations. Here we are trying to extract the numerical solution of ordinary differential equation. One such method we have is Taylor series method. This method is used to find the solution of y with respect to x, that is f of x, where y is depending on the variable value of x. So let us consider first order differential equation of the form dy by dx is equal to f of x comma y. So we call it as first order because the highest derivative is 1 here, with the initial condition y of x naught is equal to y naught. That is, x is equal to x naught, y will be at the point y will be equal to y naught. So for this kind of differential equation, what will be the solution of y with respect to x? That is what we are going to study with Taylor series, and the solution in this case will be of the form series solution. As the name indicates, the solution will be in terms of series, where n number of values of x can be substituted to find the different values of y. So the formula here is y of x is equal to y naught plus x minus x naught y naught dash plus x minus x naught the whole square by 2 factorial y naught double dash plus x minus x naught the whole cube by 3 factorial y naught triple dash. Similarly, x minus x naught whole power 4 by 4 factorial y naught fourth derivative, and goes on. Depends on how much order or degree they asked us to find, we can extend the formula accordingly. Here y naught, x naught are the initial conditions. X is the value for which we are going to find the corresponding y value. And here y naught dash, y naught double dash, y naught triple dash, and so on are the corresponding derivatives for the given function. So let us try and understand with the example. So let us consider an example here. Employ the Taylor series method to obtain the approximate solution of y at x is equal to 0.2. Since it's a numerical technique, the values will be an approximate and it will not be an exact value for the function. So this is the given function, the first order differential equation. So we can start the solution by considering the given dy by dx is equal to f of x comma y, where here dy by dx is given as 2y plus 3 e to the power x. Consider the initial conditions. So what are the initial conditions here? Y of x naught is equal to y naught, and it is given x is equal to y of 0 is equal to 0. Comparing, we get x naught is equal to 0, corresponding y naught is also 0. These are the initial conditions. Dy by dx is nothing but y dash. We can also express it as y dash. So y dash is equal to dy by dx, and that is equal to 2y plus 3e to the power x. Now we are supposed to write the formula, and in the question it is not mentioned of how much degree we are supposed to expand the formula. It is well and good if we find up to fourth or fifth derivative. So we will write the formula up to fourth derivative. So Taylor series formula, y of x is equal to y naught plus x minus x naught, y naught dash, x minus x naught the whole square by 2 factorial, y naught double dash, x minus x naught whole cube by 3 factorial, y naught triple dash. Similarly, x minus x naught power 4 by 4 factorial, y fourth derivative. It is well and good up to fifth derivative. Fourth is also fine. So here we can see, we know y naught, we know x naught. We are supposed to find the value of y when x is equal to 0.2. So we have all the values except these derivatives. So we will start finding its derivative, and we'll start substituting the values also. So y dash is given by, y dash is given in the question, that is 2y plus 3e power x. So we need y naught dash. That means y and x has to be expressed with the initial condition, that is 2y naught, because we are finding y naught dash. Y will be converted to y naught, and x will also be expressed in terms of x naught. Initial condition is given, y naught is 0 and x naught is 0. So when I substitute, first term becomes 0, second term is 3 into e power 0, which is 3. E power 0 is 1. So y naught dash is equal to 3. Similarly, you need to find y naught double dash. For that, we are supposed to differentiate the given function. So y dash is 2y plus 3e power x. Differentiate with respect to x. So on differentiation of y dash becomes y double dash, and we are differentiating with respect to x. So it is 2 into y dash, because here we have y and you are differentiating with respect to x, plus 3 is constant, e power x is e power x. But I need y naught double dash. So express everything in terms of the initial condition, y naught dash plus 3 e power x naught. Y naught dash, just now we got the answer as 3. So y naught double dash is equal to 3 into 3 plus 3e to the power 0. Sorry, it is 2 into 3. So how y naught double dash is equal to 6 plus 3. So we have got y naught double dash is equal to 9. Similarly, keeping this as your function, differentiate this with respect to x once, so that you get y double dash, y triple dash. So we are going to differentiate y double dash with respect to x. So on differentiation of y double dash, that will be converted to y triple dash, that is equal to 2 y dash becomes y double dash plus 3e power x remains the same. Expressing it in terms of initial condition, y naught triple dash is equal to 2 y naught dash plus 3e power x naught. Y naught double dash is 9, substitute it, added with 3. So how much we get? Y naught triple dash is equal to 21. Similarly, the fourth derivative, using the third derivative, differentiate y triple dash with respect to x. So when I differentiate y triple dash, that becomes the fourth derivative, that is 2 times of differentiation of y double dash becomes y third derivative plus 3 e power x. How many times you differentiate, it becomes 3 power x. Express in terms of initial conditions. All the values we have from the previous term, substitute it. Y triple dash is 21. 21 into 2 plus e power x naught. X naught is 0, so it is 3. So 21 into 2 plus 3, so totally we get 45. So y fourth derivative is 45. So whatever is required for the formula we have got. Now we are supposed to substitute back to the function. So formula of Taylor series, y of x is equal to y naught. Y naught is 0 plus x minus x naught. X is 0.2 minus x naught is 0 into y naught dash. Y naught dash we have got it as 3 plus x minus x naught, that is 0.2 minus 0 the whole square by 2 factorial into y naught double dash, which is 9 plus 0.2 minus 0 the whole cube by 3 factorial into 21. Similarly, the last term 0.2, that is x minus x naught the whole power 4 by 4 factorial into y fourth derivative, which is 45. Carefully simplify using the calculator. On careful simplification, the value of y at x is equal to 0.2 is 0.8110. That is y of 0.2 is equal to 0.8110. So this is how you have to evaluate a given function with respect to the x value. You will get the corresponding value of y. If suppose you have to find different values of x, means in the formula do not replace x by any value. Let x be x itself. So finally you will get a polynomial. In the polynomial you can substitute different values of x so that you can get the corresponding value of y with one polynomial. I hope this method is clear to all. Meet you in the next video. Thanks for watching.